All right, so I have one more question, guys, on this problem that we just solved. If you were to get the acceleration here, how would you get the acceleration? You guys want to do this together?
ايه دكتور انا هيك كان سؤالي لانه
Okay, so we have the velocity given to us as r prime ur plus r theta prime u theta. So if I want to find the acceleration, it's going to be equal to r double dot مظبوط minus r theta prime square ur plus r theta double dot plus 2 r prime theta prime u theta. Okay. All right, how can I find that right now? So I have already calculated that r prime was equal to how much? 100 sine theta times theta prime. What is theta double dot, by the way? Can someone tell me?
Is it zero?
زيرو
Why?
لانه تتا برايم از كونستنت.
Bravo, exactly. Yes, theta prime is constant, so theta double dot is 0. So now we are here. If I want to get, so I need our r double dot to be able to plug it here. What is r double dot?
cosine theta theta prime plus theta double prime 100 sine theta.
No, okay, 100. When you differentiate sine theta, it will be cosine theta times theta prime, مظبوط? But we already have a theta prime here, so theta prime square, مش هيك؟
Theta prime square.
Yes.
Plus 100 sine theta double dot. Are we good?
And u prime v, v prime u.
So A is going to be equal to how much? So I'm going to do this. So 100. So R double dot. So 100 cosine theta prime times prime square plus, okay, no, here cosine theta. 100 sine theta. So double dot minus.
بس isn't زيرو دكتور هيدي؟
Yep, this guy is 0. Exactly. This guy is 0. Minus R theta prime square. You are. Well, I already know R, right? We know R is a function of theta, so we're not going to change that. And then this guy is UR.
We basically know everything in the equation, so we can find it.
Exactly. Plus 2 R prime theta prime. We have already calculated that. Okay, guys, is this all good? Okay, so really that is all that you have to do, okay? Okay, guys, so I think we're done with this. So we're going to actually revisit those a little bit in the next chapter where we actually start looking at the forces and relating these with forces, etc.
هذا maximum
I'm sorry?
هذا الماكسيموم انه يكون complicated chapter
Yes,
problem.
yes, exactly. If you understand where we are right now and then you fully understand, you know, how we're relating these, you know, most likely you're going to do very well in the course. If you are able to understand all these very well and you are doing the assignment, there are a lot of tricks in the assignments, okay, that I don't cover here. So make sure you are doing all the assignment on your own, and you want to really sit down and do all the assignment problems that I've already posted on Blackboard. It's very important, guys. And you know, try to also, you know, solve assignments and maybe, you know, sample exams from the internet. So if you go on Google and you search, you know, for sample exams, so there's a lot of universities that actually have that open courseware available, like, you know, very, you know, prestigious universities like, you know, MIT or Berkeley, like big universities. So you can actually look into their exams, and then you can solve them. And that is how basically make sure you really understand dynamics, because dynamics is a very core course basically in mechanical engineering that if you understand it very well, you can really use that skills into understanding how basically things move, right? That you could later use into, you know, once you understand the dynamics of how objects move, you can basically control them, right? So you can get into control theory, you can get into, you know, robotics, you can get into later if you want to do like finance even. This is a very important course. Okay, guys, so what next thing that I want to discuss is compounded pulley systems, basically. I'm pretty sure many of you have seen, you know, like cranes, basically. And, you know, cranes are used to increase like the mechanical advantage, basically. If you have a force somewhere, you can basically get force, you know, you can amplify the force using a pulley. All right. So I have a question for you guys. If I have a cable, right? If I have, let's say, a wall, and here another wall, right? And if I want to have a cable, and then I want to keep that cable, in tension all the time, how can I do this? What would be the best way to basically keep that cable in tension? If I literally just bolt it here and then bolt it here, it's going to be very hard for me to create tension, right? And even if I actually have tension as a result of creep, basically, the tension will actually reduce at some point, right? Because as a result of, heating this, and then, hot weather, cold weather, etc., the cable will basically creep. How can I keep that cable in tension? Can someone think of a few ways of me to basically keep
We
that?
can put a pulley at the middle of the rope and rotate the rope around the pulley and then connect it to the other wall.
I can put a pulley.
A pulley on one side, on one wall maybe, and then pull it from down.
You want to put a pulley on, exactly, yes, bravo, exactly. I think that you got it very well. So I can put a pulley, right? Is that what you said? Okay.
Yes.
Okay, now what?
And then pull it from down side. So it comes at 90 degrees and then goes to the wall.
Exactly, so this is what I can do. So I can basically bring the cable like this, and then I can actually put a weight here, right? You guys agree? Okay, so they actually use this in, if you actually ever been in an electric train, for example, right? Or a high speed, or just any like subway system or whatever. Or these trains basically that actually get the electricity from the top, you know what I'm saying? So the train would be like here, for example, right? Etc. Right? So the train actually get the power from top basically, and then they actually use the system to keep the cable in tension. You don't want to put a spring, right? Imagine like if you put a very large spring, right? The spring ultimately will creep and whatever, like you will actually lose some of the tension of the spring, and it's very expensive. Versus you can do a very simple design basically, right? And then you can keep the cable in tension very easily, right? Now I have another question. Let's say here I have a weight M. What do you think the tension is going to be in this cable here?
mg.
Exactly.
mg.
The tension in the cable is equal to mg. How about the tension in this cable right here?
Also
Should
mg.
be also
Also
mg.
mg.
Same.
Also mg, exactly. Why? Because basically you're applying the torque about the center of the pulley. So later on we're going to see, when T and T is going to change. The only time where actually T will be different than T is if you are accelerating the pulley. And when you are accelerating the pulley, some of the torque is used to actually accelerate the inertia of the pulley. In this chapter, we are neglecting the inertia of the pulley. We assume here IG is 0 basically. So the tension here is going to be equal to the tension here. Even it doesn't have to be 90 degrees. No matter where you are, basically the tension will always be the same. Okay. Now I have a question for you guys. Okay, and this is for if I want to actually for the same weight, if I want to actually double the tension here. Okay, for the same weight, I would like to actually create 2T instead of 1T. How can I do that? And I can give you one more pulley. Let's say you want to add one more pulley. Let's say I gave you one more pulley, and I would like you to use that pulley to double the tension in that cable. Right? So for the same weight, I want to double the tension. Can you think of a way to do this?
البولي نحطه وين ما بدنا يعني قصدك؟
Yes, exactly. You are free to basically put the pulley whatever that you want. Can you think of a way where you could put the pulley to double the tension in the line?
Above it? No.
Yeah. Okay. Well, okay, I'll tell you how you do it. So if you want to double the tension on the pulley, what you should do is you come here, you actually put the pulley right here. Okay? And you keep your older pulley, whatever that it was, right? So this is a pulley here. Okay, so okay, maybe can someone help me from here? So if I actually have a weight here. Same weight. Can someone help me? How do I wire the connection here?
من الوال to the left then up then to the right to the pulley يعني انت للمقاس.
Can someone guys help me? How can I continue this wiring? I want to basically make a tension here to be equal to 2 mg. Okay, so this is what you should do, okay? So this line basically,
To the left.
well, basically for this guy to be 2 mg, basically, I need to pull this guy with 1 mg here and then 1 mg here, right? You guys agree? So I need to pull with 1T and then 1T on this end. So basically, all I really have to do is this wire, basically, I'm gonna actually bring it, okay? And then basically, so this wire is gonna come like
Connected
this.
to the center of the pulley.
Exactly, right? Yep. So this is what you should do. Okay. So if I do this, basically, what is the tension in this line? 1 mg, right?
Yes,
How about here?
1 mg.
And here, 1 mg, right?
1 mg.
So I have basically 2 mg. Basically here, I'm neglecting the angle, all right? So by doing this, basically, you can create that to be 2 mg, okay? So that is basically how suspension cables basically are tension. Sometimes you can actually have more than that. Maybe you should think of a way to actually, how we can make this 3 mg, right? Work on a design because our time is up right now. So work on a way how you can actually triple the tension for the same weight, basically, by adding maybe 1 more pulley or 2 more pulleys, I don't know. Think of it, and well, next time, basically, we will hopefully get done with the last portion of this chapter. So basically, Monday, I think we'll be done with this chapter, and we'll go from there. Okay, guys, so we're done with this. Any questions, you can let me know or send me an email, or I'll see you guys on Monday at 11.
دكتور
Yes.
بس T equals to mg هي على السنتر تبع البولي.
So here it doesn't actually have to be at the center. So this could be tied like anywhere, right? So maybe to the wall even. You can even hold this on the wall, right? So
But the
here
one which is to mg is always to the center of the pulley.
yeah, exactly. So here the center. So basically, you put a bearing, and then you connect this to the bearing on the pulley.
Okay.
Does that make sense? So sometimes
Yeah.
this guy could be like like a piece of metal like that, basically, right? And then you can connect it to here, right?
But the piece of metal is in the middle.
Yeah. So you have a bearing basically to allow the pulley to rotate, and then you can hold the cable to this one, right?
Okay.
And again, this guy could also be like that. So this pulley is obviously connected to the wall, right? And then maybe like a bracket that has holes in it, right? So I can bring the cable and then I can, tighten it on this bracket.
Okay.
Okay, guys. So, so we're good with this. So I'll see you guys on Monday at 11. Make sure you keep solving the assignments that we have. And to keep yourself, it's a marathon, right? To keep yourself going along with the course and not, be behind. Okay, guys, so that's it for today. See you guys on Monday.